So the focus of this video is going to be balancing tires. We've already now mounted a tire on a wheel. The next step is we want to balance that tire. It's very important that the tire balances all the way around. In the case of a tire balance issue, you'll notice this when a vehicle gets to approximately 60 to 65 miles per hour, you'll start to notice a vibration in that tire which can be felt through the vehicle. So following this step properly is really important, both for the comfort of driving the vehicle, but also for the longevity of the components. It will make components last longer. It will also make the tire last longer. If you have a tire that's out of balance, it's going to make that tire wear out much more quickly. So we want to make sure that we have tires balanced properly. The first step in balancing the tire, if we have not done so already, sometimes this is done before the mounting process, is we want to remove the wheel weights from the tire that are currently on there. We're going to do that using this tool, the wheel weight tool, and we're basically going to grab onto that wheel weight and remove that wheel weight from the wheel. Now this wheel has one wheel weight on the outside that we're going to remove first. That's one weight removed. We'll spin the tire around. And there's no weights on the back side of this tire. So we're ready to start balancing this tire. Now the balancer we're going to be using in this particular video is a Coates brand balancer. It's a very high-tech balancer that has a lot of capability, but the process is very similar regardless of what type of tire balancer it is that you are using. We want to go ahead and remove the center cap from the wheel. That can simply be pushed out from the back side. And we're now ready to locate the cone that best fits inside our wheel. Once we've located a cone that fits tightly and will center our wheel, we can slide that onto our tire machine and place the wheel on as well. It's very important that the wheel assembly centers on this machine, so that's the purpose of that cone. That cone allows this wheel to find its center. We can then install our cap. In order to begin to install the cap, it's spring-loaded, so we're going to lock our threads in place, and we're going to simply thread this down over our wheel while guiding our wheel into place. It's important to ensure that the hub on the back of our tire machine is sitting flat against our wheel. If it is not sitting flat against the wheel, we will get incorrect readings as we balance this tire. So we'll go ahead and we'll tighten up on our locking nut, and the wheel should spin nice and freely and nice and true. We now need to tell the machine some information about our wheel. The first thing that we need to do is we need to indicate where our wheel is located relative to the machine. On older tire machines, we had to take a measurement and we would actually type this number into the machine. In this case, we have an arm that will actually do this for us. We're going to take this arm, we're going to lift up on it and slide it out against the inside of the wheel, and that beep indicates that the tire machine has located that position. It's measuring two things. It's measuring the distance away from the machine as well as the diameter of the wheel. Again, the edge of this measuring device needs to sit against the inside ridge of the wheel. When you hear the beep, it's registered that number, and it's indicated two things on our screen. Note, two important numbers are now being indicated on our screen. The wheel is 2.9 inches away from the machine, and the wheel has a diameter of 14.5 inches. The last piece of information we need to know is the width of the wheel. There's two ways that we can indicate the width of the wheel. The first is using a caliper that looks like this. We place that caliper around our wheel. And when I read this caliper, I see that I have a reading of approximately 6.5 inches for the width of this wheel. Now, because this wheel is a size that allows us to use the hood, we actually don't have to do that. Because this wheel is a size that will fit within this hood, we can actually use the hood, the sensor on the hood, to measure the width of the wheel for us, and it saves us even that step of having to plug in the width of the wheel. What we can do is simply pull down on this hood. It's going to measure the width of the wheel, enter that number into our machine, and it's going to spin the wheel up and look for the areas of imbalance. So we'll go ahead and do that now. So you can hear now that this wheel is spinning. It's indicating that, oh, we have an issue here. As you can see, we have an error that says that the hub is loose and that we need to tighten it and respin. So we'll go ahead, if you get a message like that, lift the hood again. And sure enough, our hub was loose. The machine is sensitive enough to pick that up. We'll go ahead, we'll pull down on the hood, and we'll respin this wheel. Okay, once the wheel comes to a stop, we can lift our hood, and we can check out what weight is being called for in order to balance this wheel. What this machine has done is it's found the areas of imbalance in the wheel and determined how much weight is needed in order to balance this wheel out. As you can see looking at the numbers on the screen, it's calling for 2 ounces on the inside of the wheel and 1.75 ounces on the outside of the wheel. Now, the location of those weights is also determined by the machine. So what it's doing is it has actually stopped the wheel where it wants us to put the inbound weight. And for the inbound weight, it also gives us a line where it wants that weight on the tire. So we'll go ahead and we'll locate a 2-ounce weight. So once we've located our 2-ounce weight, we're going to go ahead and line it up so the center of the weight is even with our laser line. And we're going to use the other side of our weight tool as a mallet, and we'll tap that weight into place. Now, it's important to note, aluminum wheels are thicker than steel wheels, and therefore they do use different weights. So we want to make sure we're using the correct weight for an aluminum wheel, which is what this is. Once we've installed that weight, we'll hit the next button, and that will rotate the wheel to the location of our outboard weight. Now, unfortunately, there's no laser pointer for our outboard weight, so we kind of want to just center this weight the best we can over the mandrel. And we'll tap that weight in place. And we'll go ahead and respin our wheel. After our respin, you can see that it's calling for 0 ounces on the inboard side and 1/4 ounce on the outboard side. We don't even have a 1/4 ounce weight. So there's a couple different ways we can address that. If we were to leave this wheel as is, we would never see an issue. A 1/4 ounce is never going to cause enough of a vibration for anyone to notice. The second alternative would be to look at where it's calling for that weight. It's calling for the weight in almost the same location that it called for the original weight. So in that situation, we could take that weight off and put a 1/4 ounce heavier weight in that spot. Or we can try putting a 1/2 ounce weight somewhere near there. The 1/2 ounce weight is the smallest weight that I have. I don't even have a 1/4 ounce weight. So there's no way for me to add a 1/4 ounce. The only other alternative would be to take that 1/2 ounce weight and cut a little bit of weight off of it. So as you can see, by moving my original weight over a little bit and adding a ½ ounce to the outside of that, I was able to get 0 on the inboard and 0 on the outboard side. This is a 0 balanced wheel. We're ready to remove this wheel, reinstall the center cap, and put it back on the vehicle. So again, this is the process of balancing a wheel. There's a lot of different tire balancers out there. There's ones that are as simple as just being a bubble at the center of basically a circular platform that you place the wheel on. Spin balancers like this are obviously much more accurate. There are some lower tech balancers, but really what it boils down to is convenience, where you have to take some measurements and plug some numbers in. This takes the measurements for you and saves you a little bit of time. It doesn't matter when you're balancing one wheel, but when you're balancing, let's say, 4 wheels on one vehicle and then going to the next vehicle and trying to be as efficient as possible time-wise in doing that, it can save you a lot of time at the end of the day. Thank you everybody for watching.